Hi, welcome. I'm Abhijit, product manager here at Google Cloud, working on GPU reliability, observability, monitoring areas.
And I'm Abhay, a senior staff software engineer here at Google. Today, we are here to talk to you about Google's GPU reliability initiatives.
Abhay, as we enter this era of multi-trillion model parameters, compute is no longer an utility. It's a massive capital asset.
You're right, Abhijit. In our industry, the time to market really matters. Our customers expect a highly reliable GPU infrastructure to run things on. So today, we are going to talk to you about two things. One, what Google has done to provide a highly reliable infrastructure for your workloads. And two, what can you do to monitor your workloads and make sure there aren't any interruptions?
So Abhay, what happens behind the scene? What do we do before we deliver GPU capacity to customers?
The goal here is simple to identify and isolate all hardware problems before they can interrupt our customer workloads. To do this, we partner and work with NVIDIA very closely during the product initiation phase. Once these GPUs land in our data centers, our multi-tiered qualification process starts. First, we run foundational tests. This is where we run things like NVIDIA SMI, DCGM, and NVIDIA field diags to really stress test these GPUs, to push them to their thermal limits, and to validate the NVLink interconnect. Once those tests pass, we move on to the second phase, which is the bill of health phase. This is where we use the Nemetron framework to run simulated workloads to further validate the GPUs. In the upcoming release, we are going to make this bill of health report available to you as part of delivering the capacity. We keep our tests up to date all the time.
Super cool, Abhay. Thank you. It's great to know that we partner with NVIDIA early on and prioritize reliability in the initial design stages of the product.
Our job doesn't end there, Abhijit, does it? Can you tell us what happens after we deliver the capacity to our customers? How can they monitor their workload to avoid interruptions?
That's an interesting question, Abhay. We shift our priority at this point on the key metrics like MTBI and good put. MTBI is mean time between interruption, and good put represents the true utilization of the infrastructure as customers run their workloads. To calculate these, we capture telemetry metrics from various different sources, starting from a single GPU all the way up to the stack from the networking layer as well. To demonstrate this, I want to walk you through a GB300 observability experience. GB300 is the latest GPU offered on Google Cloud as a bare metal solution with A4X Max instance. So this is a reservation for a single NVLink domain, which has 18 machines. There are 3 instances running on these 18 machines. Each of them have 4 GB300 GPUs. Everything looks healthy. There is one sub-block. So let me take you through a pre-configured observability dashboard experience. The dashboard is named as Cluster Director Health Monitoring. And this is where we display all the key metrics and insights. Let's look at some of the metrics. We show metrics like SM utilization, thermal margin, GPU power, and GPU temperature. These are key metrics to help customers monitor the GPU utilization. If we zoom in on GPU temperature, you see there are 3 instances emitting the temperature value. We don't stop there, Abhay. We have also built reliability insights utilizing these telemetry in our usage for our always running passive tests. One such insight is about giving visibility into repairs and maintenance. So as we detect certain repair requirements, we want to notify customers early on with a 7-day warning before we disrupt their running VM. Let's look at one more demonstration. So what you see here is we detect a thermal spike in our H200 A3 Ultra GPU VM, and it crossed our threshold. So per NVIDIA recommendation, there seems to be a problem which we have to take this machine for further diagnosis. Rather than killing a running VM, we send them a notification in the log telling that we detect a temperature spike and customers have to send these machine to repair. We give them 7-day advance notice and they can decide the right time within these 7 days to send it to repair. We name this as emergent maintenance feature, which is one of the popular features by our customers because this significantly improves their mean time between interruption.
That's awesome. Thank you, Abhijit. To summarize, we prioritize GPU reliability right from the time the GPUs land in our data centers to the time our customers run their workloads on them.
To learn more about Google Cloud GPU initiatives, check out our blogs or contact your sales or account teams. Thank you.